Hi everyone, welcome back to another video. We're going to take a look at this electrostatics problem. Question 7.1, a small negative charge Q placed at a fixed distance from charge sphere Q experiences a force F as shown in the diagram below. So we can clearly see here that Q has a negative charge and it's being attracted, or it's experiencing a force to the left. Now, since Q is negative and experiences a force towards Q, it means Q must be positive, right? And for positive charges, the electric field always points away from them toward the negative charge. So if we had to draw the electric field pattern for question 7.1, we'll have a positive charge for Q, and we're going to have our electric field lines. Remember, the electric field lines do not cross or touch one another. And since it's positive, it points away from the charge, like so. Okay, question 7.2. Sphere S is attached to the ceiling by point P by a light inextensible string. When sphere R on an insulated stand is brought close to sphere S, they repel, and sphere S comes to rest with the horizontal distance between the centers of the spheres equal 0.03 meters. Sphere R is directly below point P. The string makes an angle of theta with the vertical as shown in the diagram below. State Coulomb's law in words. Again, we'll leave out the definitions for now and we'll just move on to 7.2.2. Draw a labeled free body diagram showing all the forces acting on sphere S when it is at rest. So sphere S, it has a mass, so it's going to experience gravity, so Fg points down. Then it's attached to a rope, so it's going to have tension. So the tension force will be like this, slanted. So that's Ft. And it's experiencing a force of repulsion from R. So R is pushing it to the right. So it's experiencing a force to the right. Let's call that Fe. So electrostatic force. So those are the three forces. Next question is, sphere R has a charge of 6 nanocoulombs, sphere S has a charge of 3 nanocoulombs, and a mass of 0.15 grams. Calculate the angle theta. Okay, so first thing I would like to do here is I would draw a triangle, right? And this triangle is going to be from the forces that we just did. So I'm going to draw an arrow going down for gravity, like so. Then I'm going to have the electrostatic force to the right. And then I'm going to have the tension force, like so. And what's important to know is that since this sphere is at rest, they tell you here it's at rest, it means that all the forces are in equilibrium. So when you draw your triangle, you should be able to draw a head-to-tail diagram or a head-to-tail triangle. So you can see in this triangle right here, we have a head-to-tail. All of the arrows are touching the tail of the next arrow. Now let's put in our labels. So here we have Fg, here we have Fe, and this is going to be Ft. Now what's important is we need to figure out where the angle theta is going to go. So the angle theta, let's just clear this. Right. So the angle theta is the angle that the tension or the rope is making to the vertical. So you can see right here, and then that means theta will go right there. Now if I want to work out theta, I can use the trig function. I can say that tan theta is equal to Fe divided by Fg. It just avoids us having to work out Ft, right? Though if you wanted to work out Ft using Pythagoras, and you could do that, but it's just a longer method. And so if we want to work out theta, theta is going to equal, so the inverse, and then Fe over Fg. Now we need to work out what Fe is, we need to work out what Fg is. So remember, Fe is equal to K Q1 Q2 over R squared. So K is 9 times 10 to the power 9. Q1 is the first charge, so let's go 6 times 10 to the minus 9. And then Q2 is 3 times 10 to the minus 9 divided by r squared, so 0.03 squared. So that's Fe. And then Fg is mass times gravity. So the mass they've given us is 0.15, but we need to divide that by 1,000 because we want it in kilograms, multiplied by 9,8. So we know our Fe, we know our Fg. Now you can work it out separately if you want and then substitute it back. But if you want the most accurate answer though, what you can do is you can include the whole thing. So 9 times 10 to the 9, and then 6 times 10 to the minus 9, then 3 times 10 to the minus 9 divided by 0.03 all squared. Then that's all over 0.15 over 1,000 times 9,8. You put that all in your calculator and you get an answer of theta being 6,98 degrees. And that's it. Thanks so much for watching. I hope you found this useful. Don't forget to like, share, and subscribe. I'll see you in the next video.